at first we found the area between one curve and the x-axis. Then we found the area between two curves. Well, now that we're into volume, at first we found the volume when there was only one curve, and we used the disk method. But what if there are two curves? Well, the similarities between area and volume are quite large, in fact. If we look at the area between two curves, remember that idea was the integral from a to b of f of x minus g of x dx. Right. We had subtraction involved. We needed to find the difference between the two functions in order for us to get that proper zone that was above the lower function but below the upper function. Well, now we're going to take that zone and we want to revolve it around an axis of revolution. Well, that was our disk method. So our disk method dealt with the idea of pi out front times the integral from a to b of our function being squared dx. Well, what if we were to merge these two? Right? We're kind of taking the best of both worlds. We're taking our difference from the area between two curves, but we also are taking our idea that we're making a bunch of disks. Okay? So we have the idea of the pi r squared h, or the function squared with the pi coefficient. That's where we're heading with our washer method. All right, why is it called the washer method? Well, when we take this region right here, again, we have two radii. All right, we have the radius that goes from the center to the outer edge of our region, and then the radius that goes from the center to the inner edge, all right, which I've got here in purple, and the outer edge is in orange. Well, when we revolve that region around, in essence, it's still a disk, but there's a hole in the middle. And what's known with, if you've done any building at all, that's a washer, all right? So we use that to help with nuts and bolts to actually keep everything tight, whether it's what's underneath your chair or something that's in the car engine. That's a washer. And we have a whole bunch of washers, hence the reason why it's called a washer method. We're going to add up all those volumes. So once again, we've got the addition happening. Now, because it's a whole bunch of volumes and those are cylinders, we've got the pi out front and we've got our function being squared. But there are two functions and we want the region in between them. So we want the difference of the two functions, hence we get our subtraction from up here. So we still have our difference, right? But we need the radii. So we have to square each of the individual functions. So just be careful, it's each one squared. It's not the difference squared, it's the it's each square, and we're finding the difference of that. All right, so now we wrap that because of course we need our differential, and it's happening as x approaches from a to b.